Hello everyone, welcome to the channel. In this video, I'm going to show you how to monitor the carbon monoxide air pollution using Sentinel-5P imagery in Google Earth Engine. Let's get started. Urban air pollution is a significant environmental concern affecting human health, climate, and overall quality of life. Among various air pollutants, the carbon monoxide is a critical gas emitted from vehicle exhaust, industrial activities, and biomass burning. The high concentration of carbon monoxide can lead to severe health issues, including respiratory problems, cardiovascular diseases, and neurological disorders. To effectively monitor and analyze the air pollution, the satellite-based remote sensing data provides a cost-effective and scalable approach. Sentinel-5P satellite from Copernicus program offers a high-resolution atmospheric composition data, enabling the assessment of air quality over a large area. The study aims to analyze the carbon monoxide pollution over a given study region using Earth Engine. First, we're going to define a region of interest. Next, we're going to process our Sentinel-5P carbon monoxide data to compute a time series analysis from 2019 to 2024 and generating a time series chart for carbon monoxide pollution over the selected urban area. And last, we're going to export this processed image for the analysis and visualization. To analyze the carbon monoxide pollution over a given study region, first we have to define our region of interest. To define our region of interest, we're going to define a variable called urban coords, represents the urban coordinates. These which represents the latitude and longitude of the study region. You can define your study region of your choice, for example. You can define your study region just by navigating this option here. Draw a rectangle. I'm going to draw a rectangle. Our region of interest will be this particular study region, that is Thailand. I'm going to select the entire Thailand here. You can able to see here. Once you selected this, we have a new variable called variable geometry, polygon, 4 vertices. And here we're going to click this option called show generated code. This code will contain the latitude and longitude of our newly created study region. I'm going to copy this latitude and longitude. Using Ctrl C, and I'm going to paste this latitude and longitude in this variable called urban coords. I'm going to select this and I'm going to paste this particular latitude and longitude of this newly created study region. Now we have managed to paste our latitude and longitude of our newly created study region. I'm going to exit this and I'm going to turn this off. And next, this variable contains the latitude and longitude of the study region. Next, we have to convert this variable into a polygon. In order to do that, we're going to define another variable ROI, which represents our region of interest, equals to earthengine.geometry.polygon urban coords. Using this particular set of function, it's going to convert our this particular variable containing latitude and longitude into a polygon. Next, to center this particular layer, we're going to define map.centerObject ROI, that is our study region. This is our study region with a specific zoom level, a suitable zoom level of 5. And to add this layer, we're going to define map.addLayer ROI with the default visualization parameter, and we're going to output the layer name as ROI, that is our region of interest. In our next step, we're going to load and process the carbon monoxide data. In order to assess our carbon monoxide level in this study region over the period of 2019 to 2024. First, we're going to define this particular time period for our analysis. Our time period of start of year of analysis will be 2019 and the end of the year will be 2014. This is the analysis time span. First, we're going to define a variable start year. I'm going to mention the start year as 2019. And the end year, end of the analysis year, we're going to define a variable end year equals to 2024. Next, we have to load our Sentinel-5P carbon monoxide dataset. Let me explain about this particular dataset. This is Sentinel-5P NRTI CO, that is carbon monoxide, the near real-time carbon monoxide dataset. The dataset availability is from 2018 to 2025. And the dataset provider is European Union, ESA, Copernicus. And using this particular code, you can access this particular dataset, carbon monoxide dataset, over the period of time from 2018 to 2025. The description about this particular data, the carbon monoxide is an important atmospheric trace gas for understanding the tropospheric chemistry In certain urban areas, it is major atmospheric pollutant. The main source of carbon monoxides are the combustion of fossil fuels, biomass burning, and atmospheric oxidation of methane and other hydrocarbons. Whereas the fossil fuel combustion is the main source of carbon monoxide at northern mid latitudes. The oxidation of this isoprene and biomass burning plays an important role in the tropics. So now let us visualize the details about this particular band. So the resolution of this particular band is around 1000 meters. So this is the global level carbon monoxide dataset. So it has a resolution of around 1000 meters. And in that, we're going to specifically select this particular band called carbon monoxide column number density. So because this particular dataset video, we're going to deal with the carbon monoxide concentration. So we are selecting this particular band, the carbon monoxide column number density. And the unit is given as mole per meter square, and the minimum and maximum value. And the description about this particular dataset is it is the vertically integrated carbon monoxide column density. So let me get back to Earth Engine. So in order to perform our analysis, first we have to load a Sentinel-5P carbon monoxide dataset. So for that, we're going to define this variable called CO, which represents carbon monoxide. CO collection equals to Earth Engine.image collection Copernicus S5P NRTI L3CO, representing our carbon monoxide dataset. And in this particular dataset, we're going to select this particular band. So this band is going to give us a carbon monoxide concentration in moles per meter square. So from this dataset, we're going to select this particular band called CO column number density. So this particular band it's going to give us the carbon monoxide concentration in moles per meter square. So for that, I'm going to use this function called .select function, .select CO column number density. So it's going to select the carbon monoxide band. Next, we're going to filter with a specific time period. So I have already mentioned the time period starting from 2019 to 2024. So for that, I'm going to use this function called .filter date, the start year and the end year. So I've mentioned the start year as 2019 and the end year as 2024. So next, I'm going to filter with a specific our region of interest. So I'm going to use this function .filter bound. So ROI, which represents our region of interest. So in the next step, we're going to generate a list of years and month. So for carbon monoxide concentration, we're going to generate a list of years and month. So for that, we're going to define a variable called year list equals to Earth Engine list sequence and Earth Engine number so here the Earth Engine number parse, which converts the start variable, for example, the 2019 into a numeric format. And similarly, the Earth Engine number parse end year subtract 1. So it's going to ensure that list stops 1 year before the end year, for example 2023 if the end year is 2024. So now we have managed to create the year list, and similarly we're going to create a month list. So to create a month list, we're going to define a variable called month list equals to Earth Engine list sequence 1 to 12, which represents January to December. So it generates a list of sequential numbers from January to December. So next, to visualize it, we define print year list and print month list. So I'm going to run this and let us visualize the code here. So you can able to see in the console section here, we have this first print as the year list starting from 2019 to 2023. And similarly, we have a month list which start from January to December, or January to December 1 to 12. So you can able to see that. So next we're going to compute the monthly average carbon monoxide level. So to generate our monthly carbon monoxide level, first we're going to define this variable called monthly carbon monoxide equals to the Earth Engine.image collection. So here the Earth Engine.image collection, which represents our Sentinel-5P image of carbon monoxide, and the year list, which refers to this particular variable we have created. And in that, we're going to create a loop function .map function year. And inside the loop function, we're going to return the month list.map. We're going to create another loop function. So month list refers to this particular variable here, which which creates us the sequence list from January to December. And inside this loop function, we're going to create a variable called monthly image equals to the carbon monoxide collection, referring to our Sentinel-5P image collection. So you can able to see here, this is our Sentinel-5P image collection. And inside we're going to dot filter the carbon monoxide data for the specific year. So for that, we're going to use dot filter earth engine dot filter dot calendar range start year and the end year and the unit, that is an year. And similarly, we're going to filter with the start month and to the end month. So based on the to filter based on the month, so we're going to use dot filter function earth engine dot calendar range, the start month, that is January, and the end month, that is December. The unit is month. So it's going to filter the carbon monoxide data for specific month. And last, to compute the mean monthly carbon monoxide, that is mean monthly carbon monoxide concentration, we can define this function called dot mean function. And next, we're going to create a timestamp for each month. So this is a very essential for time series analysis, ensuring each image is linked to its respective month. So we're going to create a variable timestamp equals to earth engine dot date dot from YMD, that is year, month, and one which represents the first day of the month. And we're going to return monthly image dot set system time start and timestamp dot millisecond function. So it adds the metadata of system time start to the image using timestamp dot millisecond function. And at last, we're going to mention dot flatten function. So the flatten function converts the nested list of images into a single image collection. So this ensures that each image in the monthly carbon monoxide represents 1 month of the carbon monoxide data. And now to display the monthly, the mean carbon monoxide concentration layer, we're going to define map.addLayer monthly carbon monoxide dot mean function to acquire mean monthly carbon monoxide concentration, and dot clip based on our region of interest. And we are setting a minimum value of 0 and to a maximum value of 0.05. So this is the minimum and maximum value of the carbon monoxide concentration. And the color palettes, so blue, yellow, and red. So red, which indicates the highest level of carbon monoxide concentration, and the yellow, which indicates the moderate level, and blue, which indicates the least. And we can output the layer name as average carbon monoxide concentration. So in our next step, we have to generate a carbon monoxide time series chart in order to visualize the carbon monoxide concentration. So to do that, we're going to define print ui dot chart dot image dot series. Image collection, we are referring to monthly carbon monoxide concentration. So you can able to see here the monthly carbon monoxide. And the region is based on our region of interest, that is ROI. This is our study region. And reducer, so in order to acquire a mean carbon monoxide concentration for each month, we're going to apply the statistical function, that is dot earth engine dot reducer dot mean function. And the spatial resolution of this particular time series chart have mentioned is 7000. You can also mention as 1000. The spatial resolution of this particular image is 1000, but in order to increase the speed of computation, we have mentioned as 7000. So and the X property is system time start. And you can also set other options to this time series chart. For example, the title as monthly carbon monoxide level from 2019 to 2024. And the V-axis gonna mention the carbon monoxide concentration as moles by meter square. And the H-axis is gonna mention the year. And the color of the line can be mentioned as red. And the point size of the and the color of this graph line can be given as in the red color using the series 0. So the color we're going to represent as red. And similarly, the size of that point can also be represented with a specific size here. For example, you can able to visualize this chart here. So the point size I'm going to mention as the point size is 4. So let me run this code. I'm going to navigate to this option called run and click run script. So now let us visualize it. So in the content section, we're gonna see our time series chart for the carbon monoxide concentration for the study region. So you can able to visualize here. So first, let us take a look at the the carbon monoxide concentration image here. So we have specifically selected the study region as a Thailand here. So I'm going to navigate to the layer sections. So now we're going to click this setting option here. So here, begin in the custom section, I'm going to select the stretch type to be 90%. So we're going to visualize the concentration of carbon monoxide for the study region. So the carbon monoxide concentration for the study region ranges from 0.027 moles per meter square to 0.041 moles per meter square. So you can also add some more colors in order to visualize the highest level of carbon monoxide concentration versus the lowest. So for example, I'm gonna select the red and I'm gonna remove this. So I'm gonna add more colors to it. For example, I'm gonna add an orange color to it. And next, I'm gonna add a red color. And last, I'm gonna add a pink color to it. And now we're gonna click OK. So I'm gonna click Apply to visualize the result. So here the study region you can able to see. So the pink, which indicates the highest level of carbon monoxide concentration. So I'm gonna adjust the transparency of this layer. So you can able to see here. So towards the northern section of the study region has the highest level of carbon monoxide concentration, and the red, which indicates the red and pink, which indicates highest level of carbon monoxide concentration, and the orange and yellow, which indicates the moderate level of this concentration, and the blue, which indicates the lowest level of carbon monoxide concentration. So you can able to see here the study region. So entire Thailand has a high level of carbon monoxide concentration. So you can able to see. Also gonna turn off this layer. So from the study region towards the south eastern part of the southeastern part of the study region has the lowest level of carbon monoxide. You can able to see from this image. This particular area has lower level of carbon monoxide concentration. And let me take a look at the study region. So which is situated here, closer to Cambodia and Vietnam. And now let us take a look at the time series chart of the study region. So the carbon monoxide level for this study region. So we have selected Thailand. So we're gonna visualize it. So here you can able to observe from here the carbon monoxide, the monthly carbon monoxide level from 2019 to 2024. So this axis represents the carbon monoxide concentration in moles per meter square, and this axis which represents in year. So from this you can able to visualize the highest level of carbon monoxide is observed during March, and the lowest were observed during July, and similar scenarios in 2020. So highest were observed in the March and the lowest level were observed in July. So it has a similar trend you can able to see here. So in 2021 the highest observed in the March and the lowest which is observed in July. So only in 2022 the concentration of carbon monoxide has decreased in the comparable compared to the previous years. So you can able to see the April during April the concentration was high, and the similar trend during July the concentration has dropped, but in 2023 the concentration has reached to its peak level around 0.045 moles per meter square, and similarly it has lower drop to in July. You can able to see 2023 around it's dropped monoxide, the carbon monoxide level during July was around 0.026. So let me get back to Earth Engine, and you can also download this particular time series chart of carbon monoxide level for each year as a CSV file format. So I'm going to click this option called download CSV. So I'm going to mention this CO, carbon monoxide, and I'm going to click save. So make sure that you navigate your suitable file location where you could like to save this. So I'm going to save here, click OK, save, and I'm going to open this. So in the Excel you can able to visualize here. So this is the for each month the carbon monoxide level is given here from 2019 to 2023. So you can able to see. So you can also create the chart using this particular. So for each month, you can able to visualize the carbon monoxide concentration here. So for example, during March, the concentration was around 0.048, and subsequently it has dropped for in July, August, September, and October and November, and it started rising from starting from Feb to April. The concentration of carbon monoxide was increased during this set of months for this specific study region. And in July to October, November, the concentration has been dropped. So in this way, you can also download as a CSV file format. So I'm going to navigate to the Earth Engine. So next, to export this carbon monoxide image to a Google Drive. So we're going to export the carbon monoxide concentration image. So this is mean carbon monoxide concentration from 2019 to 2024. So for example here, so to export this, we're going to define export.image.to-drive, and the image we're going to mention as monthly carbon monoxide dot main function dot clip ROI, which represents our region of interest. So the description we're going to give carbon monoxide mean 2019 to 2024, and the spatial resolution. So you can reduce this resolution. So the resolution of this particular data set is around 1000 meters. So mention the scale as 1000, and the region gonna define that is of a study region, ROI, region of interest, the max pixel level, the max pixels, and the folder where you could like to export your Google Drive, and CRS, that is coordinate reference system, EPSG 4326. So to export this image, we're gonna run this code. And once you did that in the console section, so we have to click this option here in the console. So we have this task called unsubmitted task, carbon monoxide mean 2019 to 2024. So to export this image, we're going to click this option called run. So a new window pop up saying initiate image export, and the task name is carbon monoxide mean 2019 to 2024, and the spatial resolution is around 1000 meters. So we're going to export to our drive, and the drive folder is air quality analysis, and the file name is carbon monoxide mean 2019 to 2024. The file format is geotiff, and to export this image, we have to click this option called run. So now let's take a look at the application of this particular analysis. So applications, the air pollution monitoring and public health. So helps in identifying the high pollution zones and tracking the long-term carbon monoxide variations in the urban area, and supports the public health research by correlating the carbon monoxide exposures with the respiratory diseases and cardiovascular issues. So it assists the government agencies and environmental organization in formulating the pollution control measures. So second application is urban planning and traffic management. So the carbon monoxide pollution trend can be linked to a vehicular emissions and industrial activities, aiding in traffic management strategies and facilities the implementation of low emission zones and urban greening policies. And the third application is the climate change and environmental research, so which provides data on carbon monoxide variation, which influence atmospheric chemistry and climate, and supports studies on air quality climate interaction, especially in the region affected by extreme weather events, contributes to understanding the role of urbanization in atmospheric pollution dynamics. So in this video, I have shown you how to monitor the carbon monoxide air pollution using Sentinel-5P image for any study region in Google Earth Engine. So thanks for watching, and make sure that you subscribe to our channel and give us a like.